Hey YouTube, Booth Dog back. Let's go ahead and jump right into today's lessons. Your participation seems to be pretty consistent, but that doesn't mean it's as high as I would like. So please, it doesn't really do much good for me to say this here. But if you're not watching the videos, please watch them. I realize that means you probably aren't watching this now. But really, if your friends aren't doing their work, especially you seniors, some of you need this class to graduate, you need some of your other classes to graduate, still matters, okay? Push yourself, keep going, okay? So let's bring Mr. Boothman on, and let's get started. All right, good morning, happy Wednesday. It's our first day of our 2-day Unit 10 review. You won't hear too much from me today. I do, like usual, just want to kind of summarize the main concepts from the unit here together, and then I've posted plenty of practice problems along with some answer keys for you to work through and check your work. We'll work through some of those problems in tomorrow's lesson. Today's exit ticket asks you to submit any questions you have about Unit 10 overall. That's, as always, due by midnight tonight. This Unit 10 exam will be this Friday. Yes, it will be digital, it will be through Google Form, so I'll share more about that format later on. There is no unit tracker due with this unit exam, okay, just to clarify. This is a little small, you probably can't see it here. I'm going to post this PowerPoint for you so you can see how I summarized the main concepts. This is really just a list, it doesn't actually explain what these are, so I do want to go through this a little here, and then I expect that you're reviewing with your notes as well. Section 10.1 was geometric series. So geometric series, we talked about the differences between a sequence and a series. A sequence is a list of numbers, an ordered list of numbers. A series is a sum. So whether we have a partial sum, we're adding through a certain term, or we have an infinite sum, we're adding the entire sequence. That's called a series. We talked about the difference between converging and diverging. So whether our series sums to a finite number, that's called converging, or our series sums to infinity, it doesn't actually equal any specific value at all, that's called diverging. After that, we reviewed what a geometric series is. So a geometric series is a series where the difference between one term and the next is a common ratio. We multiply by this ratio to go from one term to the next, okay? And if that common ratio is between -1 and 1, then our series, our infinite sum, will converge to the value a1 over 1 minus r. 10.2 talked about power series. Power series are a special type of geometric series where that common ratio equals x. Okay. Now, we used power series to approximate certain functions. Since it's a geometric series, if r is between -1 and 1, we know what that infinite sum sums to. So we can use this to approximate function values. Moving on from power series, we looked at Taylor series in 10.3. Taylor series totally depends on information about the function as well as the derivative and higher order derivatives at different points. We looked at the general formula for finding terms in a Taylor series. We talked about the difference between a Taylor polynomial and a Taylor series. Okay, a Taylor polynomial is finite, it approximates a function. A Taylor series, provided that it converges, represents a function. In some sense, we can say that it equals the function. Maclaurin series is a special name for a special type of Taylor series. This is the Taylor series that's centered at x equals 0. Beyond that, we looked at finding specific terms and general terms of Taylor series in 10.3. We spent quite a bit of time on that. 10.4 was the remainder theorem. Okay, so we talked about Taylor's theorem that helps us find Lagrange error bounds. So we know that our Lagrange error bound must be less than or equal to, that remainder term must be less than or equal to that whole absolute value mess of a formula. Okay, so refer to your notes for that. And we talked about how alternating and decreasing series have a special way of finding error bounds as well. So again, refer to your notes. We did some examples with that. We looked at those formulas. It's just something to remember to watch out for. Finally, section 10.5, we looked at convergence. We said that a series is really only useful where it converges. Otherwise, who cares? It doesn't actually give us useful information about a function. We had some special vocab for convergence. We have the interval, radius, and center of convergence. Center of convergence is, of course, where our series is centered. The radius of convergence is how far away from that center our series will converge. And then the interval of convergence is our interval where the series converges. We looked at harmonic NP series, so some special types of series, okay? And most importantly, we looked at a number of tests for convergence of a series. Starting with the nth term test, this was actually something we looked at earlier in the unit, but we came back to it here. Showing that a geometric series converges and what it converges to. We have the alternating series test, and perhaps most useful, we had the ratio test. So please refer to your notes, look back through each of these tests, study them, practice them, do some example problems. Like I said, I posted reviews from both halves of this unit, so everything before break as well as everything we've done since, as well as some answer keys. I'm asking you today to work through as much of these as you can. Tomorrow you'll continue to work through them. I will work through some of them in tomorrow's video lesson. Please check your answers with the answer key. Join our Google Meet if you have any questions, if you would like me to go through any of those problems in particular. Complete your exit ticket by midnight tonight, work on that review, and I'll see you tomorrow. That's it for today. Thanks, Mr. Boothman. Thanks, all of you. Let's keep going. Let me know if you have any questions. Come to our Google Meet. See you tomorrow.